Hi everyone, so this is a great quick factoring review of things that you learned to do in both Algebra 1 and Geometry and that we've spent time this year working on. This is also be a really good review for someone in Algebra 1 if you just finished factoring or even getting ready for Geometry. So first, I always think it's important to go through a factoring quadratics checklist. And so that would be number one. The first thing you always want to do is identify if it's a quadratic. So how do we do that? We look at the highest exponent. If the highest exponent is 2, then it is a quadratic function or equation. A function if it's two variables, x and y, with inputs and outputs, or an equation if it's set equal to a number and there's only one variable. Quadratic form, so that would be x squared, we'll say. Quadratic form could be something where it's an even power. So like x to the fourth, we call that quadratic form, and we may be able to factor it using some of the techniques that we factored quadratics with, x to the sixth. So for now, we want to be at first identify if it's a quadratic, because we solve linear and a quadratics differently. So then next step would be to check and see if there's a GCF, a greatest common factor. That's step one no matter what. No matter if you're doing grouping, three terms, special factor patterns, you always want to look for a GCF first, and you factor it out. After that, you count the terms. Everything we do in factor has something to do with the terms. It's either going to have 2 terms, 3 terms, 4 terms, and possibly more than that as we move on to harder polynomials. All right, so let's look at 2 terms. If it's two terms, first I always check for a GCF. So that might be like this one, 2x plus 8. It has a GCF of 2, pull it out to the front, I'd be left with x plus 4. And there's nothing else I can do, so I've factored it completely. After GCF, I want to look for factor patterns. One pattern is the difference of 2 squares. I refer to that as dots. Dots. So I look for dots. Dots, the factor pattern is when both terms are perfect squares and there's a difference, meaning they're being subtracted. So in this case, a squared minus 4. So a squared minus 4 is 2 terms, they are perfect squares, and they are being subtracted. So we could factor that into a plus 2 and a minus 2. One thing to always remember is that dots means that the factors are different. They're not the same. All right, a couple more examples. 3x cubed plus 15x squared. All right, well, I notice they have a common factor of 3 and x squared. I pull out both. That leaves me with x plus 5. There's nothing I can do within those parentheses, so I've factored it completely. 4x squared minus 49. I look to see if it's dots, and it is. So that would be 2x plus 7 and 2x minus 7. All right. Now, it's very easy with dots when you look at perfect squares to actually jump to conclusions and forget that GCF is still our most important first step. So in this case, while both 16 and 4 are perfect squares, they also have a common factor of a 4. We want to pull that out first, leaving me with 4x squared minus 1. Now, I look to see if I can factor it any further, and I can. That's dots. So I can factor that to 2x plus 1 and 2x minus 1. All right, a little bit more challenging is when I give you something that it's not exactly the same. It doesn't look exactly the same. But I can see that this expression, because it's raised to the 2 power, is a perfect square, and 9 is a perfect square. So guys, that means that you can factor it using the pattern. So that would be x minus 1 plus 9 and x minus 1 minus 9. Then I simplify to x plus 8 and x minus 10. Now, you could certainly FOIL that out or multiply that out and then factor it, but I just think it's easier to notice the factor pattern of dots. Now, one thing I don't want you to get into a habit of is actually thinking that the pattern, they have to be perfect squares. If I have 2 terms, maybe say x squared minus 7, you can actually factor that using the rule of the patterns. The pattern is that you're basically taking the square root of both terms, and that's what's going in the parentheses. So in a case like x squared minus 7, you actually could factor it. You could say x plus root 7 and x minus root 7. All right, so that's dots and 2 terms. 3 terms is the one we spend the most time working with. So when I get to 3 terms and I've taken out a GCF, my first thing is I really want to know the factor pattern, perfect square trinomial. I always look for this first. Now, if your teacher didn't spend a lot of time on perfect square trinomials, I highly recommend you go back to my video on that, perfect square trinomials, because this is a really important factor pattern as it tells me so much about the graph, and it's going to make things much easier for you when you complete the square, when you are trying to recognize different things that relate to circles and hyperbolas and ellipses. Such a really cool factor pattern, so we're really going to want to pay attention for it. If it's not a perfect square trinomial, I'm going to look at the A term to see if it's 1 or not 1. And then I could use several methods. I could use the AC method, which is the grouping method, or guess and check. However your teacher taught you to do that in the past, I'm comfortable with you using. All right, so how do I tell if something's a perfect square trinomial? Well, the first term is a perfect square, and the last term is a positive perfect square. The middle term, regardless of the sign, would be if you took the square root of the first and the last term and you multiplied them, that number would be double that. And so in this case, 3x doubled is 6x. All right, so how do we factor it? Well, the pattern is your result of a perfect square trinomial is going to give you a binomial square, or the square of a binomial. It's always going to be the square root of the first term, the square root of the last term, and the sine of the middle term. So x minus 3 squared. All right, a little harder, numbers are bigger. Perfect square trinomial, I don't know. First term's a perfect square. Last term's a positive perfect square. Those roots are 2x and 3. 3 times 2x is 6x. 6x doubled is 12x. It is a perfect square trinomial. So 2x plus 3. Now, in order for it to be perfect square trinomial as well, this number would have to be even because you're doubling it. So that should kind of make sense to you. All right, after that, we look for GCFs, but then we factor according to the rule. These 2 examples, A is 1. All right, so we're looking for the sum and the product, so sum product. So 2 numbers that multiply to 56 that add to negative 1. Hopefully you're seeing that would be x minus 8 and x plus 7, because negative 8 times 7 gives you negative 56, and negative 8 plus 7 gives you negative 1. X squared plus 11x plus 30, it's going to give me x, and what, 6 and 5, plus 6 plus 5. All right, moving on. A term not 1. I verify if A term's not 1. I verify I took out a GCF. And in this case, I didn't. So I'm going to take out a GCF of 2, leaving me with x squared minus 6x plus 4. Is that right? All right, now in this case, there are no numbers that multiply to 4 that are going to add to 6, right? 4 and 1, 2 and 2 will never add to 6. So you have factored it. It is in its lowest form. All right, moving on. 2x squared minus 11x minus 6. All right, so this is when it's a little bit harder. I'm going to have you try it using the method you're comfortable with, whether that's the AC method, grouping, or guess and check. Okay, if that one is uncomfortable to you, I would like you to go to my video on factoring when the A term is greater than 1. 2x squared minus 11x minus 6 can be factored. 2x plus 1, x minus 6. I don't want to go into detail on that only because many teachers teach this many different ways, and I want you to go with what you know how to do. If you want to practice this with me, I'm always available, so come see me, okay? All right. I'm going to move on to grouping. Okay, I'm going to move on to grouping. So if it's 4 terms. If it's 4 terms, I do have a video on this as well, but we're going to try it. When it's 4 terms, we group together 2 of the terms, pulling out a GCF. I'm going to try by grouping together the first 2 and the last 2, although you don't need to group those together. All right, so I pull out their greatest common factor, in this case, p squared, and I'm left with p plus 9. I go to the second group. I see they have a greatest common factor of a 4, so I take out a positive 4. You always want to bring that sign with you, and you're also left with p plus 9. If these factors are the same, then you've grouped it properly. Now, the hard part about grouping is recognizing that that actually is the greatest common factor. So it now gets pulled out to the front, and you're left with p squared plus 4. You always want to check to make sure you can't factor any further, and in this case, you can't. All right, guys, we're going to do some more of that, but that was just a quick review of factoring, trinomials, or quadratic equations. These are quadratic expressions because we are going to be using this to solve quadratics and see what all of those numbers actually mean. All right, have a great day.